Hello, my name is David Foreman with Interactions, and today I have with me Matt Shoemaker. And we are going to be presenting big data and agile business intelligence and how Insights was able to create actionable business insights from big data using a variety of tools, processes, and technologies. So, for the background, I am the Director of Business Intelligence for Interactions, been with the company for about 9 months. And Matt Shoemaker is the Business Intelligence Architect. So let's begin. Our agenda today is first to give the audience and everybody here some background about Interactions and talk about what is big data to Interactions, and then talk about more specifics. For Interactions, what was the big data question? What type of insights did we find, and how did we come up with our solutions for big data? And ultimately some questions and answers. Interactions is about experiential interactive marketing. We have in-store, outdoor, and insights. Our different offerings, and in-store we do product demonstrations, sampling, coupon, concierge, and taste tests. Outdoor, it's much more about interacting at events such as sporting events, or grand openings, guerrilla marketing. And finally, we have an insights division that focuses on customer service management, mystery shopping, customer intercepts, the full range of being able to interact with customers. And what does that mean? It means that we are interacting with millions of people a year, running millions of events, generating enormous amounts of data from both our internal systems as well as data that we get from our customers. But perhaps to give you some context, it'd be best if I showed you a video about our company.
Workforce of over 45,000 associates execute more than 2 million events every year. That's 5,500 events every single day. We engage people and drive sales for our partners on 3 fronts: in-store, outdoor, and through insights. You and your family are out enjoying the weekend when a carnival full of color, sound, and excitement captures your attention. As you approach, the sights and sounds of the event come to life. Brand ambassadors introduce you to new products. They invite you to play games and award your participation with coupons to redeem in-store. Interactions outdoor marketing events deliver sustained increases in market share and brand awareness. That is the power of outdoor marketing. Making your way through the store, you see strategically placed sales and marketing events. The atmosphere ignites all 5 of your senses. You smell the aromas and see the excitement of the crowd. You hear the sales advisor inviting you to try a sample. You hold the product in your hand and taste it, all while the sales advisor educates you about the quality ingredients and demonstrates the ease of preparation. The sales advisor closes the sale, but before leaving, you snap a picture of the QR code on the product side so you'll have recipes on hand when you get home. Interactions in-store events produce the highest sustained sales lift of any in-store tactic. That is the power of in-store event marketing. During your shopping trips, an Interactions coupon concierge offers you special discount coupons and directs you to the location of the products. The interaction with the coupon concierge prompts you to purchase additional items. Interactions Coupon Concierge program delivers redemption rates of 25%. That is the power of Interactions Coupon Concierge. As you leave the store, a friendly field agent asks about your shopping experience, store conditions, buying habits, and quality of customer service. Your feedback is reported in real time through wireless tablets. Store operations can review the data immediately and respond without delay. The Interactions Insights team increases customer loyalty, maximizes product sales, and keeps our partners from losing millions in potential sales. That is the power of Shopper Insights. Interactions is your source for in-store product demonstrations, outdoor events, and Shopper Insights. We are your single-source partner for experiential marketing events that engage people and drive sales. Find us on the web at interactionsmarketing.com.
So as you can see, interactions does thousands of events a day, billions a year, interacting with tens and hundreds of millions of customers. And that generates a lot of data. Generates customer data from mystery shopping, where we ask questions and we get insights from people. It also generates enormous amount of data from sales and how much our product demonstrations drive sales lift. When we talk about big data, we have to ask ourselves, what is big data? I always like to go out to Wikipedia. Wikipedia has great, very detailed definitions. I'm not going to read off for here, but a quick summary. Wikipedia defines big data, and they talk about large and complex, and they talk about the challenges for how you capture and you curate the data. But and I found Wikipedia very, very detailed, but sometimes it's not as easy to understand, and sometimes it's hard to put it into context. So we've developed what we consider to be a simpler definition. The big data challenges is that the traditional tools that we use, whether it's traditional databases or software techniques, do not work when we talk about the volumes increasing. And one of the important aspects I want to talk about is the relative nature of big data. For some people, big data is petabytes of data and trillions of records, and they have challenges managing that amount. For interactions, it's different. We had billions of records and gigabytes and terabytes of data, and we found it difficult to do analytics with the tools that we had in place at the time and the constraints those tools put on us. So when we boil down, we ask ourselves, what is big data for us? It's the amount of volume, and it's the term that we use is when the big data, especially when we talk about our vendors, it's the technology that we need to be able to effectively use that data across our tool sets in the ways we want to. If we were having tools that could run an analytics and it takes half an hour, our users get very tiresome, they walk away. So we had to find tools that allowed us to interact with our data in real time or near real time, and we didn't have that. So that's why we went out and we started to look for how we were going to solve this problem. We'll talk a little bit about that more later on in the presentation. But what I really want to emphasize is the big data challenge can be relative. In my hometown, I have a series on Main Street. There's stores. And one of the stores that is one of my favorites is a used bookstore antique shop. And I was in there a few weeks back with my son, and he was looking for books. And while I was working, while he was walking to the store and while I was looking through there, I came across a used copy of Big Data for Dummies, and I was reading the book and seeing what the content when Michelle, the owner of the store, asked me, she says, if I was interested in big data. And our conversation carried on, and she willingly, after I dragged it out for a little bit, admitted that she had a big data problem. And when we talk about the relative nature of it, she had one. For her small business, she had tried to start off with using Word to manage her mailing lists. Quickly became too difficult. She then tried to use Excel, and it could handle more data, but then she had to do mail merges, and it became way more difficult to manage both her mailing list and her inventory, and she just was spending too much time, and the data was overwhelming her. So she set out and she discovered that she could find in this case, a web-based solution that was much easier to use, and she was able to solve her big data problem by moving to a CRM solution that was out on the web. I think that's important context for our session today, that each one of us has a big data problem, but it's going to be different. We don't have to expect that we're going to answer today in our presentation how we solve a problem with 1 trillion records. But what we will focus on is that we had a problem with a much smaller set than that, but we needed to come up with a solution. So let's move on. What was Interaction's big data question? The business came to the business intelligence team Interaction and said, we want to understand how significant weather events impact shopper behavior. What happens when there's, for example, a major snow event? What happens before, during, and after? You can see here, we quickly went to Tableau, and we have some nice little maps here. It shows us where areas were heavily affected by the storm and not heavily affected, and we can see here that there's clearly a drop in sales. Looked easy. So what was so hard about that for interactions? Let's first talk about what we are using for our analysis. We have up here a Wikipedia entry about the Groundhog Day blizzard of 2011. This is a very significant snow event, impacted a very significant number of people, about 100 million. And in certain areas, you saw significant snowfall, 1 to 2 feet of snow. We then asked ourselves, can we compare that year with the previous year and the post year? Seemed like a very easy question. So we sat down with the business and said, we need to put this all together. We need to understand what the scope of this analysis is, what you want to accomplish with the analysis, and what are the success measures of this one. So the very first thing we set off to do is define it, and we decided we're going to look at the grocery trade. We're going to focus initially on 3 specific categories: alcohol, grocery, and produce. And the weather event is going to be both the snow depth and the rate of snowfall. We decided to narrow it down because, of course, we had to look at winter. January, February, March, we looked at 2010, 2011, and 2012, and we were considering before, during, and post-sales events. So we were looking over, and I'm going to give you an example of what that means. We wanted to make sure that when we were comparing same day to same day. So, for example, if Wednesday, February 2nd, 2011, we were going to look at the same day in 2010 being a Wednesday, regardless of whether it was February 2nd or not. It may be the 3rd, maybe the 1st. We were comparing year-over-year sales to the same day a year ago and year after. We had sales data from multiple retailers, and we combined it with weather data from the National Oceanic and Atmospheric Administration. What happened? Well, with the technology we had, we couldn't do it. We had SQL servers, but when we tried to put all this data in and blend it, we tried to run it against Tableau. Fairly simple analytic analysis, what we call exploratory analytics. Our servers were not powerful enough. We didn't scope our servers to be able to analyze this amount of data in seconds. We run some things, and some queries ran 10, 20, 30 minutes, and some queries actually timed out and never completed. The other challenge that we had was about our data storage. We had to blend data together, and we had hundreds of gigabytes of data, and we did not have that data available on our network. We just simply don't plan to be able to have iterations of files and have to store 2 terabytes of data as we were manipulating it through various cases. We'd run a blend. We would discover that it didn't quite have the results we want. We'd have to run it again. Didn't have the storage space. More importantly, the business requirement was that they did not want to aggregate data. We had to have the data at the lowest possible level, in which case was a store on a specific date with a specific product. We did try some alternatives. We tried to use the Tableau data extract engine, just simply would not work with the amount of data we had, and also we couldn't create extracts where we didn't have disk space. So we said to ourselves, we had a technology problem. How much data did we have? We had about 320 gigabytes. We were analyzing 1.3 billion rows, and we were analyzing 20 fields spread across 19 dimensions and 6 different measures that included the units sold, pricing. What I want to do now is turn over this presentation to Matt Shoemaker and give you the insights that we found within the data. At the end, we want to come back in and answer the questions, how did we implement a solution? So what we've gone through now is we understand what the big data problem was for interactions. We understand what the question was. Let's get some insights. Matt?
So first I'm going to talk a bit about the methodology we used for the analysis, and then I'm going to demonstrate the way that Tableau made it so easy to discover insights and, more importantly, quantify those results. Now, obviously, the NOAA doesn't have a weather station at each store. However, they do have several weather stations in pretty much all urban areas. So our first step was to find the weather station closest to each store, and used that to represent the snowfall for each store. In our retail database, we have the latitude and longitude for each store in which we track sales. In the NOAA data set, they also report the latitude and longitude of each weather station. So our approach was initially use the Pythagorean theorem. So for each store, we calculated the distance to every weather station, and we take the one with the shortest hypotenuse in each case. And in the slide, you can see we have store 1 in the middle there, and there are 3 surrounding weather stations. And by calculating the hypotenuse, we can determine which one is the shortest direct distance. Now this works fine for urban areas where the store has a large number of weather stations to choose from, but for rural areas, the weather stations are not as close to the stores, and altitude could become a factor as well. So we made adjustments for this in subsequent runs. For instance, to take into account the curvature of the Earth, we used the Haber-Sign equation, and we also removed some outliers. For instance, if the station is too far from the store, it would not be a good representative of snowfall at the store. And if there's a significant difference in altitude, also the same case. So those are outliers we remove. So if the weather station is situated on top of a mountain, even though it may look close on a map to the store, it really isn't a good indicator. So this viz shows the stores and the weather stations. And as you can see, each store had a weather station fairly close by, so a good representative sample to take the snowfall and snow depth data that represents each store. The blue store dot, basically the middle that I've called out there, looks like it doesn't have any weather station surrounding it, but when you drill in, you can see there are actually 2 stores and 1 weather station covers both stores. And that's a relatively short distance. So what we found is that for every store, we were able to find a good representative weather station for which to track the snowfall. Now the red marks on this viz represent stores that had a snow depth greater than 4 inches after the snowstorm. In the rest of the presentation, I'll refer to these as heavy snowfall stores. The yellow marks represent stores that had less than 4 inches of snow depth. So we refer to these as light snowfall stores. In addition to these 2 location groups, we also looked at buying patterns at individual stores. So I want to point out quickly here that when we look at year-over-year % change in sales, which is what we're looking at the bottom chart there, we're comparing the same day of week, not necessarily the calendar day. So in these charts, we're showing the calendar day for 2011 on the x-axis. But when we compare that to the same day in 2010, it is more in terms of week 5, day 3. So week 1, day 1 is always the first Sunday of the year. So week 5, day 3 is the 5th Tuesday of the year, regardless of the calendar day. So in 2011, week 5, day 3 was February 1st. But in 2010, it was February 2nd. So we're trying to normalize there by day of the week so that we don't end up comparing sales of a Saturday, which is a traditionally heavy shopping day, to a Wednesday, which is a light shopping day. So now we've normalized this by day of the week for year-over-year % sales comparisons. And now on this visualization, we're looking at overall daily product sales at the heavy snowfall stores. The orange line shows the average snow depth on each day for these stores. Now before the storm, you can see there was already about 5 inches of snow on the ground in these areas, on average. The buying level was roughly the same as the previous year, as indicated by the low year-over-year % change, in which case there was no snow the previous year. However, beginning with Sunday, January 30th, and continuing through Tuesday, February 1st, we start to see a huge increase in sales, which is several days before the snow starts to fall again. This is the run-up to the storm. The snow starts to fall heavily on Tuesday, February 1st, and it continues through February 4th, at which point it starts to melt a bit from its highest levels, again indicated on the orange line. And you can see that after February 4th, the level of snow, instead of continuing to decrease, actually stays steady. So that tells me that there's a steady snowfall from February 5th or so all the way through about February 13th. And then towards the end of the chart, February 14th through 19th, you can see the the snow depth declines rapidly. So there was steady snowfall for at least a week there. And then obviously at that point the sun comes out, the snow starts falling, and the snow depth level decreases to almost nothing. We can see that after the initial snowstorm, which again was February 1st, on the 9th we see looks like a return to shopping. So even though the snow has continued to fall, at some point people are out of groceries and they need to go back to the store. So we actually see a day there where sales increase again compared to year over year. And because that is 19%, it tells me that there probably was a let-up in the snow a little bit as well. Then a couple of days later, after sales are down compared to previous years, we also see another little bit of a run-up. And this is, at this point, is when the sun is really starting to come out and people head back to the store. So on this next slide, we're looking at overall daily product sales at the light snowfall areas. We see here that there was only a couple of inches of snow on the ground prior to the snowstorm, and the purchasing levels were about the same as last year. However, even though the snow did not fall heavily on February 1st and 2nd, like it did in the other region, there was still a pretty significant buying push on Monday, January 31st, as consumers anticipated there'd be a lot of snowfall. And keep in mind that the news reports are that a huge winter storm is approaching, and people are not really able to anticipate how much snowfall there will be, but they're expecting a lot, even though it really didn't pan out. During the period of January 1st through January 3rd, excuse me, buying is down when compared to 2010. Even though there was not as much snowfall as in the other regions, there were very high winds and cold temperatures. More than likely, people are still going to work, though, at this point, because the snow is really not falling that heavily. When Saturday, February 5th rolls around, people go back to the stores in great numbers. There's also some snowfall starting on Monday, February 7th, so it's possible that people are stocking up based on news of more heavy storms approaching. Towards the end of the chart, you can see that the snow is fully melted and buying patterns are back to normal levels compared to the previous year. On this slide, we see sales for alcohol, grocery, and produce categories. As you can see, these categories saw a severe run-up as the storm approached, but on a percentage basis, alcohol sales outpaced grocery and produce. And let's face it, if you have a choice of eating some crackers, eating an orange, and drinking a glass of wine, the glass of wine is the only one that's going to warm you up any. Having said that, please drink responsibly. So besides just looking at grocery, produce, and alcohol, we also ran the analysis across all product categories and ranked them based on their year-over-year % change in sales on one particular day, Tuesday, February 1st, which is the last run-up day. This slide shows the top 3 sales increase categories. The garden center category shows a 261% increase in sales year over year. This was followed by hardware and automotive as the top categories. Not that surprising when you think about it, really. So why garden center? There was a huge increase in sales of certain products that you would expect, such as shovels and snow blowers. But we also saw a massive increase in sales of 2-cycle motor oil, which is used in snow blowers and chainsaws. In addition to the more expected products, there were also many items that are in the garden center category that you may not usually think of. For example, charcoal grills, charcoal lighter fluid, utility lighters, and firewood bundles are also sold in the garden center. For people with an electric range, they're probably anticipating that the power could be out for several days. So that's why outdoor grills might see a spike. Another subcategory that saw a big increase was gardening gloves. This could be due to the fact that people knew they may have to do some outdoor work to prepare for the storm, or because the regular part of the store ran out of gloves in the clothing department, and this was the only option to purchase gloves. So in order to answer this, we may have to bring in some more data showing inventory levels, which was not part of this analysis. But this is a prime example of how answering certain questions leads to asking new questions and new follow-up analysis. Now, you may be thinking at this point, do I really need a big data analysis effort to tell me that shovels and snow blowers sell more in the run-up to a storm? No, probably not. But our business goal was to quantify it so that we can get the right product to the right stores at the right time. By far, one of the biggest problems for retailers in general is out-of-stock items. Oftentimes, if a consumer does not find a particular item at one store, they'll leave the store and go to another store, not just for that one particular item, but for their entire purchase. This could be a whole full cart of goods and potentially hundreds of dollars in lost sales. With the proper analysis, stores can prevent this behavior by stocking up on sufficient levels. So looking at some additional categories, we saw some interesting trends. In particular, looking at seafood and cigarettes. Now, we can use the electrical category as a reference because it shows a more typical pattern here. We saw a run up to the storm, and then sales dropped off, and then we see a couple of spikes as sales resume, and then they're kind of normal at the end of the chart here. But looking at seafood sales, you can see that sales were typical before the storm and showed a normal pattern during the run-up. However, after the storm, there was a long period of suppressed sales that didn't recover until the 5th week after the storm. Now, this is just speculation, but if I had to guess, I'd say this is probably due to supply disruptions during that time frame. Another interesting observation is that when the sales did recover, they sold at a much higher level when compared to the previous year. This could have been due to a lower sales price as a rush of seafood product flooded back onto the market. Now, we did not have the price of the product in this data set for this analysis. We actually have it in the data, but I didn't include it in this analysis. But it would be an interesting thing to look at to see if that run-up increase in sales at the end of the chart is due to a decrease in price of seafood items. Now, moving on to the cigarette category, you can see that sales were down across the board in 2011 compared to 2010. I'm sure there's a good explanation for this, probably higher taxes on cigarettes or something like that. But one thing certainly stands out. When a big winter storm is coming, people still rush to the store to stock up on cigarettes. So to wrap things up, by using Google BigQuery and the Simba BigQuery driver and Tableau Desktop 8.0, we were able to perform analysis on a totally different level from what we were able to do before. I didn't have any slides here showing sales at the location level, but this was an important part of the project. And by eliminating the need to pre-aggregate data, we were able to slice and dice the data down to those finest levels of granularity. It was really a lot of fun working on this project, and I look forward to the next big data challenge. At this point, I'm going to turn things back over to David Foreman, and he'll explain a little bit more about the approach we took to preparing the data for analysis in Tableau.
Let's recap where we are. We've learned about interactions and what interactions does, and provided the definitions of big data and what our big data question was. And Matt has provided insights as to what we found with that big data. So how do we do it? Let's take a look at the solution. The traditional approach, you get new data sources, you would take it into a staged database, you do some ETL transformation, you would essentially put it into an ODS, once again, transform it again, then perhaps put it in your data warehouse, do some analysis, discover there's performance issues, you repeat the process over and over again. This cycles take months. I've worked in very large enterprises, and this is very realistic to what we've done with large data in the past. But imagine, just imagine, what if we could get rid of some of these steps? What if we could just take the big old red marker, X out a bunch of these traditional approaches, go forward? What could we do? The concept that Interactions calls create and destroy analytics, and by that we mean that this cloud infrastructure allows us to establish storage or databases of massive volume. We need to have 500 gigabytes of storage space for our files. We don't have to wait days, weeks, months. We have to wait minutes. And then oftentimes we don't have to wait at all. We can just post data up. That gives us an unparalleled flexibility that we did not have before. So what can we do differently? We can take data sources. And through a merge process we developed that was able to tie those new data sources into our existing data warehouse, we were able to load data up to the cloud. And one of the benefits of the cloud was the enormous speed. We were getting throughput that we didn't even expect. We were able to load 100 gigabyte files in a matter of hours that were taken across our own internal network up to half of the day. And then we were able to leverage the cloud-based big data. For this one, we used Google BigQuery. And we'll talk a little bit more about some of the specific benefits of Google BigQuery in just a few moments. But one of the key aspects that I can't stress enough is that Google BigQuery allows you to take massive amounts of data from the cloud storage, load it into BigQuery at speeds that I never even imagined possible, loading hundreds of gigabytes in half an hour, run queries with zero database administration, zero tuning. We were then able to analyze by using Tableau Desktop and Tableau Online, or Tableau Server, as many of you may use. We were able to analyze data through BigQuery in an interactive mode. The ability to drag and drop, see data changing across billions of records instantly, to be able to refine analysis in almost in a manner where you would think that you were using a very small set of data on your desktop. Why did we choose Tableau for this? First off, Tableau has built-in connectors for cloud-based databases, both for Google BigQuery as well as Amazon Redshift. We did not have to go out and buy any other products. We didn't have to go out and buy any other drivers. We were able to connect Tableau Desktop, as I said earlier, online to the same data sources for the same investment. And any of us in IT today, anytime we can leverage our investment to be able to do more, that's a very good thing. As I've stressed before, we use Tableau Online, cloud-based offering. We don't host any servers. Tableau handles that for us. And yet, we're able to interact with our data through these built-in connectors and be able to share that data internally with our customers through one site. As I talked about in the previous slides, Google BigQuery takes care of the complexity. You drag and drop stuff into Tableau, it writes the SQL statements, it executes, there's no tuning, there's no optimization, it just runs. And finally, and most importantly, we set up a goal as a company. No more on-premises data center. And this is what we have today, empty space that we can use for other stuff. Talk a little bit about Google BigQuery. As I've said numerous times, and I know I'm repeating myself perhaps, but the speed and scalability was unprecedented for having worked with data sets for over 20 years. Our analysts were able to run queries that would hit 1 million records and 1 billion records in the same time frame. When I talk about time frame, I'm talking about seconds. Some of the visuals that you saw earlier, where we were plotting 1.3 billion record sets into our various graphs and our year over year, those are running typically under 10 seconds. Simplicity. In today's world, with limited resources, when we can ever do more with less, not having to have database administrators to fine-tune databases, tune them, and tell you that you need to have more processors or more memory, that's golden. And most important is efficiency. Being able to move massive amounts of data around, being able to load that data in time frames that are measured in minutes as opposed to hours or days, means that we were able to respond to requests during this project, to be able to give the business users different views of data by adding or subtracting fields in hours, not in days, months, and quarters that we typically are used to. We really feel that we should share a couple of key tips that we learned, a couple of tricks. Even though I've talked about the simplicity and the efficiency of this, there are a few things that we discovered up front that made the entire process easier. We did start off with a very small set of data that we extracted into a Tableau data extract, and we set up the framework of each one of the visualizations just because it was much easier to do, and we were able to refine specific requests and what new field requests or new calculations and put them in the data, and not have to repeat the cycle. So there is some opportunity to start off with a small set of data, refine both your model and your requirements. That can save you a significant amount of time. But when we got to exploratory analytics, we did discover a few things. If you're doing a significant number of changes where you're moving around either measures or dimensions, pause. Even though Google BigQuery continues to get optimized and has moved to a model now where the recently used queries are, instead of being re-executed, are reused, we did find that it's best to pause, make a number of changes, and then resume. And it was much more efficient and less time-consuming than having to wait each time a query ran. And one lesson I can't stress enough that we've adopted ourselves is to use clean data source. Even though there's a number of publicly accessible and free data sources out there, free doesn't always equate to no cost. We found that certain data sources, while easily available, you could pull them and extract them, had too many gaps, inconsistencies in the data. At times, paying for specific clean data would have been a cheaper route for us. Where is interactions moving forward? We are pursuing an analytic plan where we do more with weather intelligence and also start to integrate with social media insights, Twitter, for example, and expand our ability to do affinity analysis. If a customer likes A, what do they like with B, and do they like B? It's an affinity for another product C. Be able to truly understand what our customers like, as well as being able to take our data and understand how it is impacted by trade promotions and whether there's opportunities to optimize it better. And finally, the whole grail for us is be able to anticipate shopper behavior so that we can have the right demonstration and the right events at the right times that maximizes both our revenue as well as maximize the return on investment from our customers and our vendors. We continue to use these technologies. As for here today, we've invested heavily in Tableau Desktop and Tableau Online. We are using multiple tools from Google, including the BigQuery and the Prediction API, and also leveraging the Amazon Web Services. As that technology stack allows us to spin up and down instances when we perhaps need a prototype, that instead of making large investments in fixed hardware, we can spin up a server for a week, do a proof of concept, and when we're done, we can spin that down, and our investment is small, a couple $100s, instead of investing tens of thousands of dollars in infrastructure and also having to wait the lead time that we all know it takes to get new servers and storage in our data centers. What I want to leave you today is more information. We provide some links to the tools that we use, whether it's Tableau or Google BigQuery, as well as the cloud storage platforms that we are using. At this point, I would like to open up to the audience questions and answers.